We look next at a rational function. I'm calling it g instead of f. G of x equal this fraction of two polynomials. That is a rational function. Let's get g of 0. Plugging in a 0 for x, negative 2 over negative 1 gives me 2, positive 2. I put that in my table of values, and I put that on my plot. Now let's find the zeros of g, the values of x that make g of x equal to 0. Okay, a fraction is 0 only when its numerator is 0. This numerator is 0 when x equal 2. So that is d1.
So, yeah, he is.
That is the 1, 0
All right, I'll go.
of this function.
All right, thanks.
It's not much to graph it by, but I happen to know this being a rational function. This one has a horizontal asymptote at 1. And I know because the 0 of the denominator is positive 1. It has a vertical asymptote at 1. Well, these asymptotes box in a function, so to speak. So this graph approaches but doesn't touch that dotted line or that one. The dotted lines are not part of the graph. They are the asymptotes that are helping me draw it. So there's the graph using the intercepts and certain other techniques. There's the graph of a rational function. Let's move to a polynomial function. This one is of degree 3, whereas previously we had a parabola. It was of degree 2. This is a third degree polynomial. I expect 3 zeros, but I expect 1 y-intercept, because let's see, what is y of 0? Y of 0, plug in a 0. 0 minus 0 minus 0 plus 12. Let's not write all that down. Let's just do it in our heads, and we get y of 0 equal 12. I left off a little bit of that writing. Y of 0 equal 12. Table of values. Plot it here. Now let's find the x-intercepts, the zeros of the function. I set this function equal to 0. Well, perhaps you remember synthetic division and other techniques to help you find first one of the zeros, and then the others you can find by factoring. So this turns out to be the factorization of that third degree polynomial. 3 linear factors. Okay, we want to set each one in turn equal to 0, because this product will be 0 if any of these factors are. Setting the first one equal to 0, solving for x, x equal 3. Here, that will be 0 when x equal negative 2. This factor will be 0 when x equal positive 2. So if I put these in my table, no particular order, and plot them here, negative 2, positive 2, positive 3, and recalling what I know about the behavior of a third degree polynomial function, I can roughly sketch this. I'm not sure how far down it goes before it turns back up, but it captures those 4 graphs of 4 functions using the